Now I'd like to look at that same example again, but now we're going to start putting some math to it. So far we haven't been doing a whole lot of math other than just kind of crossing things out, right? So let's write a little equation for this in our first line here, right? So we're going to say that 3 boxes and 1 bearing has the same weight as 1 box and 7 bearings. And we can represent the word and with plus. And we're going to put an equal sign in to say that they're balanced. Now we're going to go one step further with that and say, well, instead of calling them boxes, let's call them n's. Okay, so this is saying now that 3n plus 1 is going to equal 1n plus 7. So we didn't include any letters for our bearings. That's okay. Let's try to avoid using as many letters as we need to. We can get away with this with just using one letter, and I'll show you how in a second. So remember before in this problem we crossed one bearing out from each side. Well, remember down here a bearing is just these digits with no letters in front of them. So to show that mathematically, we're going to write 3n plus 1. And well, what did we do on the left-hand side? We then subtracted 1. I'm going to keep my equal sign in, and I'm going to have 1n plus 7. And then what did I do to the right-hand side? Well, I did the same thing, right? I subtracted 1. Now when we look at this equation, we have 3n plus 1 minus 1. Well, plus 1 minus 1 is 0. So on the left-hand side of the equal sign, right, over on this side, what this becomes is just simply 3n. Okay? The plus 1 and the minus 1 canceled each other out. This section of it here is canceling one another out. That goes to 0. On the right-hand side, well, 1n doesn't get touched. And then we have plus 7 minus 1. Well, 7 minus 1 is 6. So on the right-hand side, we're left with 1n plus 6. Now remember our next step up at our balance puzzle. We crossed out a box on both sides. And remember we called a box n. So what that would look like on our equation down here is we would have 3n minus 1n, and on the right-hand side we would have 1n minus 1n plus 6. And just like before, this term here goes to 0, because if you have a box and then you take away a box, you're left with no boxes. And on the right-hand side, we're left with just 6. On the left-hand side, if you have 3 boxes and you take away a box, well, what are you left with? 2 boxes. So we're left with 2n equals 6. So this last one's an important step, so I'm going to transport this to my next slide. Now, one particular thing that I didn't say, although it's kind of implied, is that what's happening between this 2 and this n is that they're actually being multiplied together. So you can think of it as 2 times n equals 6. When we look at it this way, you can definitely see that the answer is going to be 3. 2 times what equals 6? Well, it's 2 times 3. But let's follow the rules to get there. And the rules say that we want to get n by itself. And in order to do so, whatever we do to one side, we have to do to the other. So as it stands, n is being multiplied by 2. And so to get rid of a multiplication by 2, we're going to divide by 2. And I'm going to show that with a fraction, and you're going to see that we're going to get away from using that division sign, this all familiar division sign, and we're going to start replacing it more with fractions. And what happens is that a 2 on the numerator and a 2 on the denominator, we say they cancel each other out, but really, if you think about it, 2 over 2 is the same as 1. So on the left-hand side, we're left with 1n. And as long as we follow the rules of whatever we do to one side, we have to do the same to the other, then we divide the other side by 2 as well. So we get 1n equals, well, what's 6 divided by 2? It's 3. So again, you can get there in your head probably pretty quickly, but we can also follow these rules. And these rules are going to help when the numbers get a little unmanageable, where you're not going to be able to do them always in your head. But for now, I'd like to look at just one last example. And now the training wheels are off. We don't even have a picture anymore to accompany this balance puzzle. But you can kind of imagine it. There's going to be 5 boxes and 7 bearings, 2 boxes and 25 bearings. See, that's a pain to draw, so this is where math is nicer. So our first step in here, I like dealing with the bearings first. If you prefer the boxes, that's fine. But I like looking at the bearings. So I'm going to try to look at the 7 and the 25 and say, well, 7's my smaller number. I'm going to get rid of 7 from both sides. And so to write that mathematically, I would write 5n plus 7, and I would get rid of it. So I'm going to say minus 7. And whatever I do to the left-hand side, remember, I have to do to the right-hand side. So on the right, I get the same thing, 2n plus 25, and then I subtract 7. Observe that plus 7 minus 7 cancels each other out. So we're left with 5n equals, and then look at what happens on this side. So we have 25 minus 7. Okay, well that would be, what, 18? So we would have 2n plus 18. Now my goal is going to be to look at these boxes and say I've got 2 and I've got 5 on each side. So I'll get rid of the 2. He's my smaller number. Those are usually easier to work with. So what I'll do is I'll start with the right-hand side of this equation, and I'm going to subtract. I'm going to take 2n, and I'm going to subtract 2n. Okay, and my plus 18 stays there. He's undisturbed over there. And remember, what I do to the right, I must also do to the left. So over here, I would get my 5n, and I'm going to subtract 2n. So you can picture what would happen over here. 5n minus 2n becomes 3n. Over here, when I take 2n, subtract 2n, they go away. I get 0. So I'm just left with my 18 on the far end there. Now for my final step, I'm going to remember that this 3 is being multiplied by the n, or the n is being multiplied by 3. And so to get n by itself and to get rid of a multiplication by 3, the opposite is going to be divide by 3. And when I do so, my 3's in a sense cancel out, or they become 1. And on the right-hand side, I'm also going to divide by 3. And so what I'm left with is a 1n equals, well, 18 divided by 3 is 6. So that means one box contains 6 bearings in this example.